Okay, we left off here. Number 3. Just like gravitational fields and electric fields, the magnetic field strength is proportional to the density of the field lines. Wherever the lines are really close, that's a strong field. Where the lines are really far apart, that's a weak field. So at this picture, right, shown here on the left side, where is the B field strength strongest? Where are the field lines most closely spaced? And the answer, it might be a little hard to see, but the answer is near the poles. That's the answer. Near the poles. The North Pole and the South Pole of the magnet. Okay. The last thing I want you to do is take a moment to draw in which way the field lines point. And do it just on the left side, and then we're going to do something else on the right side. Well, if you put a compass right here, its north pole would be attracted toward the south of the magnet. So the field lines point like this. And you don't have to fill up the whole page, you can just do a few. The only other thing I want to do is on the right side, right here, the field lines are curved. So where does the magnetic field point? Tangent to the curve, like this. Oops, it should be straight down. And because of how dense the lines are, this is a somewhat strong field at this point. Right here, the field lines are a lot farther spaced apart, so the field strength is smaller, the field is weaker. Something like this maybe, right? Even weaker out here, if we drew this. If we wanted to draw the field strength right here, we would just draw a line tangent to the curve. Right here, you would draw a line tangent to the curve. That's the idea. Okay, next page. There are special connections we're going to study between magnetism, magnets, and electricity, charges. Right? Here's one. Moving charges, charges that are going somewhere, that are moving, they produce a magnetic field. And let's write a cylindrical magnetic field. A cylindrical magnetic field. Weird. So weird, but it's true. Now, these magnetic fields are a cylinder when the wire is straight. If the wire is curved, then the cylinder kind of curves around to follow the wire. So if your current does something like this, here's the current, then the field lines will like make circles that kind of follow cylinders that follow the current around as it goes, like that. But for a straight wire, like shown in the photos, the field is cylindrical, the magnetic field. There's a rule to figure out which way those lines point. You use the right-hand rule. And it's the same as, it's very, very similar as the right-hand rule we learned for angular momentum. You point your thumb along the direction of the current, and you curl your fingers around. They start out straight, like this, right? And then you curl your fingers around toward your palm, and that curling direction is which way the B field lines point. Right? So we could add in field lines for these guys if we wanted, but it's kind of excessive, so let's not. And there's another photo here showing how the rule would work if the wire were moving up the page, carrying current up the page. Something to notice is that the loops are not evenly spaced. Okay. If you deal with negative charges that are flowing, like let's say we have a single negative charge, an electron, right? And the electron is moving to the left, to the right, then instead of using your right hand to figure out where the field lines point, you would just use your left hand for negative charges. Right? Now I want you to add a note and say current, we always assume that current is positive. Current is positive charges that flow. So if they say a wire carries a current, and they don't tell you whether it's positive charges being carried or negative charges, you assume the current carries positive charges. So take a moment, answer number 5, number 6, do 7 and 8, and 9 as well. Complete the problems in this page. Okay, did you complete the problems? Pause the video, and if you haven't paused the video, do that now and work out these problems and then come back to this page, to the video. Alright, here are the answers. Looking at the picture, where is the B field strongest? How do you know? The answer is the B field is strongest near the wire. Near the wire. And the reason is because that's where the field lines are most closely spaced. So I'm not going to write that out, but you could put that into your own words. You can say that's where the field lines are most closely spaced. You could also say that's where the field lines are densest. A proton is at rest. Does it produce a magnetic field? It's a cylindrical field, right? No! The answer is no. Why? Because it's at rest. For charges to have this effect of producing a magnetic field, for charges to do this, they have to be moving. No, because its speed is 0. Or you could just say not moving. Okay, the proton below is moving out of the page. Draw the magnetic field lines around the proton. Out of the page. So you take your thumb, and your paper is on your desk, right? So you take your thumb, and it's your right hand, because it's a proton. Right hand. And you put your thumb, put your thumb so it's coming out of the paper, pointing toward your nose. And then you curl your finger, put your fingers out straight, and curl them toward your palm, and they curl around this way. Right? And as you get farther out, the field lines are farther apart. So this is what the picture should look like. The next one would be even farther, right? Oh, running out of room. Alright. The electron below, electron, that's negative, so use your left hand, is moving out of the page. Draw the magnetic field lines around it. So you put your left hand with your thumb pointing toward you, because that's where the charge is going. The thumb points in the direction of the current. So you put your left hand, thumb is pointing toward you, like on the paper, toward your nose, and you curl your fingers. Your fingers start out like this, right? And then you curl them around toward your palm. Here's your palm, and there's your thumb sticking out at you. And the field lines point this way. They point this way. Okay? So here's the next one. Whoop. Here's the next one. Field lines that way. The next one. Try that again. A little farther apart. And I'm really bad at this on the computer, aren't I? This is not good. You can do better. Number 9. The wire shown is carrying current to the right. Current, we assume it's positive charge, so we use our right hand, not our left hand. What is the direction of the magnetic field at the point P? So this is hard to do on. You put your thumb out like this. Your fingers are pointing up like that. Right, here's your palm. And then you curl those fingers around toward your palm in 3D. And what do you get? You get cylindrical field lines like this, kind of curling around. Curling around like that. Right? And at point P, those field lines are coming literally out of the page, out toward you. So the answer is out of the page.